Okay, circle of radius 6 passes through the points 0, 0 and 0, 10. Sketch two possible positions of the circles. So our circle has to go through, we've got a pair of axes drawn here. Our circle has to go through these 2 points. Notice that these 2 points are a distance of 10 away from each other. However, because we have a radius of 6, the diameter of our 2 circles will be 12. So we can't draw a circle so there's an equal amount of circle on either side. The y-axis can't be split in half because that would give us a circle with diameter 10 instead of a diameter of 12. So we've got 2 possible ways in which we could draw a circle then. Either the majority of the circle is going to be over to the left, or the majority of the circle is going to be over to the right. Very dodgy circles there, but as long as the examiner knows, where your circles are intended to be drawn, then shouldn't be any worried about whether you're going to get the marks or not, except some dodgy circles here. Okay, 8 part B, find the equations of the 2 circles. So we already know the radius, all we need to know now is the center of the 2 circles. Now, due to the symmetry, I only really need to find the center of one, and that should allow me to work out the center of the other. So let's look at the circle that's on the right. So I'm just going to highlight roughly where the center is. What do we know about its location? Well, first and foremost, due to the nature of the circle, I know that it's going to be a distance vertically up from the x-axis, halfway along between 0, 0 and 0, 10. So halfway along will be a y value of 5. So I know that much about my center. If I now produce a right-angled triangle connecting either 0, 0 or 0, 10 to the center, and then connecting across to the y-axis, obviously that will be right angled there. What do I know about this right angled triangle? The distance from 0, 0 to the radius, 0, 0 to the center, is going to be the same as the radius. So I know that this side will have a distance of 6. I also know the distance from 0, 0 to this halfway mark up here is a distance of 5. So all I really need to know now is how far across my right angle triangle goes, because that will be in line with the x value of my center coordinate. So using some Pythagoras, I'm going to have 36 minus 25 and then the root of that. So I'm actually going to have a distance of root 11 going horizontally. So my x value here is going to be positive root 11. To go with a y value of positive 5, I'm going to have my first circle equation as x minus root 11 squared plus y minus 5 squared is equal to the radius squared, which would be 36. Due to the symmetry of the situation, the other center is going to have exactly the same y value, but it's going to be at a negative root 11. So I'm going to have x plus root 11 all squared plus y minus 5 squared is equal to 36, and those are going to be my 2 equations. Okay, question 11. Circle has following equation with the center at C, write down the radius of the circle. Given the format of the circle equation, all we need to do is take the root of that right hand side. So our radius is going to have back. The radius is going to be root 5. Write down the coordinates of C. So the coordinates of our center is going to be positive 7, negative 2. Okay, the point P lies on the circle. Find the equation of the tangent to the circle at P. Give your answer in the form of y equals mx plus c. So let's just draw a little picture. So I'm just going to do it to one side over here. So I've got a center at 7 minus 2. We've got a point P which is at 5 minus 1. So it's just a sketch, so it doesn't really matter where we highlight it. Let's just mark our point. Let's say my point P is in that location there. So I'm going to leave it P, and that's at 5 minus 1. And I want the equation of the tangent that goes through P. So a straight line that goes through P, such as that. There we go. Okay, so how do I get the equation of this? So if I want the equation of a straight line, I need to know a point that it goes through, which I already have. I know it goes through the point P. So if I think of the form y minus b equals m of x minus a, my point P is going to represent our coordinate AB, which is going to go into a straight line equation. So the only thing I really need to know now is the gradient. Now the gradient is going to be perpendicular to the radius. So if I can work out the gradient of the radius between the centre and the point P, I just take the negative reciprocal of that. So my centre is point C. So let's find the gradient between C and P. So changing y, so from -2 to -1, that is a change of +1. Let's go from 7 to 5, that's a change of -2. So that gives me a gradient of -1/2. So if I want the perpendicular gradient to this, negative reciprocal of -1/2 would be +2. So my equation of the line, therefore, will be y minus b. Now remember, b is going to be the y value of point P, which is -1. So take away -1 will be +1 is equal to the gradient m, which for us is 2, and then x minus a is going to be x minus 5. Now I need it in the correct form. I can't leave it in that form. I have to write it in the form of y equals mx plus c. So I'm going to expand my brackets on the right. So 2x, let's get rid of that, 2x minus 10. But then I need to take away 1 from this left-hand side. So 2x minus 11. So y equals 2x minus 11 is going to be my final answer. Okay, part C. The point Q lies outside the circle. The point T lies on the circle, such that QT is a tangent. Find the length of QT. So I'm going to add some additional information to my circle diagram. So I'm going to add an extra point that is on the circle, which is my point T, and a point Q which lies outside the circle. So I'm just going to draw right a point Q there, and we're told that QT is a tangent. So I'm just going to connect Q and T together. And if that's a tangent, I know that if I connect a radius to the point T, then that's going to be a right angle. Why is that useful information? Well, hopefully you might be able to predict if I consider a line that connects C to Q. If I consider a line going from C to Q, then I've got a right angled triangle there. Now on this right angled triangle, I know that C to T is just the same as the radius. So I know the radius is √5. What else are we told? Well, we need to work out the distance from Q to T. So I'm just going to call that X for now. Do I know the distance from C to Q? If I do, then I can just use Pythagoras. I don't at the minute, but I do know where Q is. Q is at the point 3, 3. So I can find the distance between these two coordinate points, C and Q, then I'm going to have the distance between C and Q. So if I want the distance from C to Q, using the expression for distance between two coordinate points, it's going to be the change in the x values. So that is going to be a change of 4 squared, and change in the y values, and that is a change of 5. So that's 16 plus 25, so that will be √41. So I can add that to my diagram. So I've got a distance of √41. So now I'm going to use Pythagoras again, but this time it's going to be to find the value of x. So I'm going to have x squared plus √5 squared is equal to √41 squared. So x squared plus 5 is equal to 41. So x squared will equal 36. So x will equal 6. And that is the length of the line segment QT. Okay, new circle equation. In the case where the circle does not intersect either axis, show that K has to lie between 100 and 164, not inclusive. Okay, so what do we know about when graphs intersect axes? Well, a graph will intersect the y-axis when x is equal to 0. A graph will intersect the x-axis when y equals 0. Now, we don't want there to be any intersections at all. So if we consider an intersection with the y-axis, what happens when I replace x with 0? So if I replace x with 0, I'm going to end up with y squared minus 16x will disappear, minus 20y plus k is equal to 0. So that's in the case when x equals 0. So I have an equation here. Now the thing is, if I end up with any solutions for y, that's actually going to reveal y-intercepts. I don't want there to be any y-intercepts, so I don't want any solutions to this quadratic. So if I don't want any solutions to a quadratic, that's equivalent to saying I don't want any roots. And if I don't want any roots, this comes from the fact that our discriminant has got to be less than 0. So we need the discriminant to be less than 0. So looking at the quadratic, my value of a is going to be 1, b is going to be minus 20, and c is going to equal positive k. So let's substitute that information in. So we're going to have minus 20 squared, which is 400. And we're going to have minus 4k, and the latter part. And that has got to be less than 0. So 400 is going to be less than 4k, and k is going to be greater than 100. And all of a sudden, we've actually ended up with what's required for the first part of our inequality. K is going to be greater than 100. So what about the situation where y equals 0? Because we don't want any intersections with the x-axis either. So replacing y with 0, we're going to end up with x squared minus 16x plus k equals 0. Once again, we require our discriminant to be less than 0 for no solutions. So in our case here, we've got a equals 1, b equals negative 16, and c equals k. So we're going to have minus 16 squared, which is positive 256, and then we're going to have minus 4k again. So what happens when I solve this? So when I solve this, 256 is less than 4k. Divide by 4, we're going to end up with k being greater than 64, which is fine, but that was already covered by the fact that we knew that k had to be greater than 100. So this is irrelevant information. If k is already greater than 100, it's definitely also going to be greater than 64. So this is an inequality we don't need to worry about because it's satisfied by the first. Now, that's all good and well, but we still haven't got k being less than 164. That information hasn't dropped out of this working, so we need to look elsewhere. So let's just consider other information about our circle. So obviously the form that's written at the minute isn't the form that can allow us to deduce a center or a radius. So let's try and get it in a correct form for deducing a center and radius. So let's just rewrite it so that our x terms are together and the y terms are together. And then we've just got a plus k at the end. Okay, so completing the square for both x and y, we're going to have x minus 8 all squared. That's going to generate a 64, which we don't want. And then we're going to have a y minus 10 all squared, and that's going to generate a 100 that we don't want. And then we've still got a plus k. Okay, rearranging this so that we've got our information that we're able to deduce the centre from, so our two sets of brackets. And let's just move everything else on the right, because everything that goes on the right hand side, when rooted, would yield our radius. So I've got minus 64 and a minus 100. When those move to the other side, they're going to become positive, and they would go together to give us 164. And the k would become negative. So from this, we'd be able to deduce that we have a centre of 8, 10. What about the radius? Well, if it's a circle, we know that it must have a radius, and for a radius to exist, obvious information, a radius would have to be greater than 0. A circle wouldn't exist if we had a radius equal to 0 or less. So we need 164 minus k to be greater than 0. For that to be true, that means 164 has got to be greater than k. Flip it round, that means that k has got to be less than 164. So let's bring the two inequalities together, and we can conclude that k has got to be greater than 100, but it's going to be less than 164. Okay, question 2. A circle has the following equation. Find the gradient of the tangent to the circle at the origin. Circle your answer. So this is a multiple choice question. It's only 1 mark, but don't be deceived. It doesn't mean it's just going to be a quick work it out in your head and find the answer. It means that the skill required is going to be relatively simple. Just make sure you don't make any daft mistakes. Okay, so what can we deduce about this circle? So we're actually told we need to find the gradient of the tangent to the circle at the origin. So what that means is that the origin must be a point that's on our circle. So the origin being 0, 0. So if I were to draw this circle, that means that the origin is somewhere that's on the circle. So I'm just going to mark it 0, 0. What can we deduce from the circle equation? We can deduce that there is a centre at the point 2, negative 3 by using the two sets of brackets. And when connected, we would have a radius. We could work out the radius, and the radius would just simply be given by the root of 13. Okay, so I need to find the gradient of the tangent to the circle at the origin. So I need to consider a tangent that goes through the origin, and I need the gradient of this. What do we know about the gradient of the tangent? We know that it's at a perpendicular to the radius. So let's consider the gradient of the radius. So the gradient of the radius, if I consider a change in y of a change in x, so let's say I'm going from 0, 0 to 2 minus 3. So change in y would be negative 3. Change in x would be positive 2. Just pull the negative to the front, so that would give me a gradient of negative 3 over 2, which means that the perpendicular gradient would be the negative reciprocal, so it would be a positive, and it would be 2 over 3. So I need to make sure it's nice and clear that I'm circling the gradient of 2 over 3. Okay, a curve has equation given as follows. A line has an equation y equals mx plus 10. In the case that the line intersects the curve at two distinct points, show where the following inequality comes from. Okay, so keyword here, we're looking at intersection points. So we consider intersection points by looking at bringing our two equations together simultaneously. So let's do that. So our line equation has y as a subject. So let's substitute y, so the expression for y, into the first equation. So where y appears in the first equation, let's put our expression in. Okay, so y equals mx plus 10. Okay, so rewriting our first equation then, we still have the x squared. In place of y, we're going to put mx plus 10, and that is all squared. Then we've got plus 12x, and then we have equals 64. Okay, let's tidy this up. And we're going to have, just be very careful, this is a double set of brackets we're expanding. We're going to have x squared plus m squared x squared plus 20mx plus 100. We've got our plus 12x on the outside, and we've got equals 64. Now, m is just a number. later on it says we need to find possible values of m, but we have to view m as just being a number. But this is an equation in terms of x. And notice that the highest power of x we have is a squared power, then we have a power of 1, and then we have constants. So it's a quadratic. So we want to rewrite this in the form of a quadratic. So we've already got our two x squared terms together, so let's factorize that x squared. So we're going to have a 1 plus m squared all multiplied by x squared. So that's my x squared term. My two x terms, though, well, they're separate at the minute. I've got 20mx and a plus 12x. So let's just look at those together. Let's take out a common factor of x. So I've got a plus 20m plus 12 all multiplied by x. I've then got a plus 100 on the left side, and then I've got equals 64 on the right hand side. Now to solve a quadratic, it has to be in the form of a quadratic being equal to 0, x squared, x term, constant, and then equals 0. So I need to take away the 64 that's on the right, which means I'm taking away 64 from 100, so I'm going to have a plus 36 and then equals 0. Now, the next part of the sentence says we need an intersection at two distinct points, two different points. So for two distinct points, for a quadratic, we require b squared minus 4ac to be greater, strictly greater than 0. Now, what are a, b, and c in our case? Well, for us, a is going to equal the coefficient of x squared, which is 1 plus m squared. B is going to equal coefficient of x, which is 20m plus 12, and then C is going to be the 36 at the end. So let's substitute those into our discriminant, and we're going to have 20m plus 12 all squared minus 4 lots of A, which is 1 plus m squared, and then we need to times by C, which is 36. And then we need discriminant to be greater than 0, so we need a greater than 0 at the end. And if we compare this to what we actually wanted to show, it's super close. All that's happened is they have brought their constants together to make the 144. So I've got a 4 and a 36, which I need to bring together. 4 lots of 36, as you might predict, is 144. So I'm just going to rewrite it so it looks identical to what's required. So minus 144 in brackets 1 plus m squared, and then greater than 0. Okay, next part, hence find the possible values of m. So from this, we can continue to solve. So let's now tidy up this information. So what's a good idea? Well, let's expand all our brackets. So let's start with the 20m plus 12. So 20m plus 12, so that's all squared. So that's a set of double brackets being squared. So I'm going to get a 400 m squared. 12 times 20 is 240, two of those, so 480m, and then going to have a plus 144. So that is all from expanding the first set of brackets. And then just be careful, I've got minus 144 times everything in the second set. So I'm going to write this underneath. I'm going to have minus 144 times 1, so minus 144, and then minus 144 times m squared, so minus 144m squared. And then all of that is greater than 0. Tidying this up, so 400m squared take away 144m squared, so that's going to be 256m squared. 144 take away 144 cancels out, so I've just got a plus 480m. That is greater than 0. Can we tie this up? Yes, we can. Let's divide through everything by 4. So that'll be 64m squared plus 120m is greater than 0. Can we divide by 4 again? I think we can. Obviously, you could use your calculator, that's absolutely fine. So divide by 4 again, so that's going to give me 16m squared plus 30m. What could I divide by now? Divide by 2. 8x squared, 8m squared plus 15m greater than 0. And then I think I'm done in terms of simplifying. Okay, now this is a quadratic. Don't divide out m. You divide out m, you're actually losing one of your solutions. So it is a quadratic. So I am going to factorize. and it's an inequality. So what I actually end up here are critical values for m, not just solutions for m, critical values. So factorizing m, I've got m lots of 8m plus 15. That has to be greater than 0. So my critical values are going to be m is equal to 0 and m is equal to negative 15 over 8. Now it's a positive quadratic inequality that we've been solving, so we just consider this expression here. That is a positive expression, so a positive quadratic. So if I consider a positive quadratic graph, it would be a U shape. Now because I'm solving for m, I have to imagine it's going through an m axis, and the critical values are where our graph goes through the m axis. So I've got the wrong way around. So I've got a negative, let me just get rid of that. So I'm going to have negative 15 over 8 as one of my critical values, 0 is the other. I need my quadratic to be greater than 0, which is above the axis. That's my greater than 0 region. So I'm looking at m being less than minus 15 over 8, or m being greater than 0. So m has got to be in either of those two regions. Okay, 7b. On the same diagram, sketch the curve and the line in the case where m equals 0. So, going back to our two original graphs, it says we have a curve, but hopefully, through our understanding of different algebraic equations, drawn as graphs, that actually that's going to produce a circle equation. The second one is a straight line, but let's just focus on the first one for now. So that is a circle equation, so we need to write it in the form of a circle equation where we can deduce a center and radius. So let's just bring the two x components together. So we've got x squared plus 12x. I'm just going to write those together. I've got a y squared, which is the only y term, and then I've got equals 64. I'm going to complete the squared for the x term. So I'm going to have an x plus 6 all squared. Generates a 36, which I don't want, so I'm going to take that away. I've got a plus y squared, which I'm going to leave as it is. I don't need to complete the square for just y squared on its own. And then I've got equals 64. And then I need to just bring that minus 36 to the other side by adding it, leaving us with x plus 6 all squared plus y squared is equal to, take away 36, what's that going to be, 28 is equal to 28. Okay, so what does that mean? That means that we have a center at minus 6, 0, 0 because y squared hasn't got a constant being added or subtracted from it, which is equivalent to adding or subtracting 0. So that's our center, and we have a radius of root 28. We could simplify it if we want. I think if we simplify, what would that be? 2 root 7 if we wanted to. Okay, so we've got that information for our circle. And we're told sketch the curve and the line in the case where m equals 0. So when m equals 0, well, what's going to happen? Well, we could just go back and say, okay, well, we've got a line, y equals mx plus 10. When m equals 0, then our line equation is going to simply be y equals 10. So that is just going to be a horizontal line. But how are they going to interact with one another? Well, if I just start by just considering a pair of axes, y equals 10 would just be a horizontal line that goes through 10 on the y-axis. Now our circle has a center at minus 6, 0. So minus 6, 0, let's say it's at that location there. Now as a sketch, I should still have my graph looking roughly in the right place, and I need to make sure my interaction between my curve, my circle, and the line are correct as well. What do I know? Okay, well, firstly, root 28. Root 28 is less than 6. How do I know? I know that because 6 is the same as root 36. Why is that important information? Well, the centre is a distance of 6 away from the origin, away from the y-axis. My radius is less than that, so I know my radius is going to mean my circle does not cross over the y-axis. It's going to be just a little bit short, so I don't want my circle to cross over the y-axis. But what about the line above, the line y equals 10? Well, just be mindful of what we found out in part 7aii. We found out that our line and our circle will intersect twice when m is greater than 0 or less than minus 15/8. Now, when m is equal to 0, that is a critical point, which means that we're no longer going to have two intersections, but it's on the fringe you're going from two intersections to no intersections. When m equals 0 as a critical point, that is going to be when we have exactly one intersection between the two. And for exactly one intersection, that means that our line is going to act as a tangent to our circle. So if I draw the circle now on my graph, there you are, then I need to make sure it's just grazing against the line. And remember what I said earlier, we know that it's not quite going to hit the y-axis because the radius is just short of the distance to the y-axis. And that is based on the fact that 0 and minus 15/8, they're the critical points between having two intersections and no intersections. So that's going to be our graph. And the final question, state the relationship between the curve and the line. We can write down the line is a tangent to the curve. Okay, bonus question. Find the coordinates where the following two circles intersect one another. Okay, so we're looking at how two circles intersect. If I'm considering intersections, then I want to be thinking of simultaneous equations. A bit problematic though, because they're two circle equations which are quite complicated to consider. So there's a few ways of going about this. Let's go for the most intuitive way of looking at them. I'm going to expand both equations so neither of them contain any brackets. So x minus 3 all squared would give us an x squared minus 6x plus 9 plus y squared minus 2y plus 1. That equals 25. I'm just going to tidy that up. X squared plus y squared. I'm just going to write those two together. Minus 6x minus 2y. And then I've got plus 9 and plus 1, which gives me a plus 10. And then I'm going to subtract it from the other side, so just bringing the numbers together. So that's going to give me an equals 15. Okay, let's do the same with the second equation. So second equation, x squared plus 2x plus 1. Then we're going to have a plus y squared plus 2y plus 1. And that also equals 25. And let's just rewrite that with x squared and y squared together. Then I've got a plus 2x, a plus 2y, and then I've got a couple of 1's which I'm going to subtract from the other side, so that's going to give me an equals 23. Okay, what we're going to do now is we're going to subtract the equations from one another. I'm actually going to call the bottom one equation 1 and the top one equation 2. I'm going to do equation 1. So we just had a hiccup there, so just had to rewrite what we've worked out so far. So we got to the point where we tidied everything up, and these are my two equations. And I'm going to subtract one from the other. I'm going to do equation 1 subtract equation 2. Okay. Now, usually when either we substitute or we eliminate, or use the elimination method, that will actually get rid of one of our variables. In doing this, you'll hopefully realize that we don't actually get rid of either x or y, but we can employ a clever trick afterwards. Watch what's going to happen. So my x squares and y squares are going to cancel out. I'm going to have 2x take away minus 6x, which is going to leave us with a positive 8x. I'm going to have 2y take away minus 2y, which is going to give us a positive 4y. And then 23 take away 15 is going to give us 8. We can simplify this. So that's going to give us 2x plus y equals 2. And then I can rewrite that as y equals 2 minus 2x. Okay, so I've not ended up with a solution for x and y. Now we are trying to find coordinates where the two lines intersect one another. I haven't done so, but what I've actually worked out here, if I just draw a sketch of the two circles, now I haven't really looked into details to what the two circles have in terms of information, but let's say the two circles look like this. In trying to find where they intersect one another, what we've got here, hopefully you recognise, is actually a straight line graph. Now this straight line graph will lead us towards finding where the two circles cross over. And the straight line we've actually found is the one that passes through the two intersection points between the two circles. So it is important information. Okay, so how can I use this line then? So what I'm going to do, I'm now going to say, well, imagine I wanted to find the intersection between the line and one of the two circles. How would I do that? I would substitute this line equation into one of my two circle equations. So let's look, for example, at the bottom circle equation. So the bottom circle equation starts with x plus 1 all squared plus. In the second brackets, instead of y, I'm going to put 2 minus 2x. 2 minus 2x. I've then got a plus 1 that comes afterwards. And then squared equals 25. What I have now is an equation just in terms of x. If I can solve this, I can find the x values of the two intersection points. So let's have a go at doing that. So I'm going to have x squared plus 2x plus 1. Let's just tidy up this bracket just to begin with. That's be 3 minus 2x all squared. So expanding that to a double set of brackets, I'm going to have a positive 9 minus 12x plus 4x squared, and that equals 25. Bring the x squared terms together, I'm going to have a 5x squared minus 10x, and what have we got? A plus 10, which I'm going to leave on the left hand side. I'm going to subtract 25 from both sides, so plus 10 take away 25 gives me a minus 50, and that all equals 0. Simple quadratic now, which we can solve by either using quadratic formula, using our calculators. Let's just divide through by 5. X squared minus 2x minus 1 equals 0. This actually does factorise quite nicely. Or does it? I take that back, it doesn't indeed. Scratch that. Into the quadratic formula, what have we got? We've got a equals 1, b equals minus 2, c equals minus 1. So x is going to equal 2 plus or minus 2 squared, which is 4. Take away 4 lots of ac, so that's going to be plus 4 lots of 1, which is 4, all over 2a, which is 2. So I'm going to have 2 plus or minus root 8 over 2. 8 is the same as 2 root 2, so that's going to give us 1 plus or minus root 2. So my 2x values are 1 plus root 2 and 1 minus root 2. Now instead of substituting this back into one of the circle equations, conveniently enough we can now use a nice straight line equation to substitute into. So let's go for 1 plus root 2. So 1 plus root 2, we're going to have y equals 2 take away 2 lots of this. 2 take away 2 lots, whoops, 2 lots of 1 plus root 2. So that's 2 take away 2 root 2. And so that is going to give us 2 take away 2, they cancel out. Y equals negative 2 root 2. And if we do the same thing with 1 minus root 2, all that's going to happen is we end up with y being equal to positive 2 root 2. So my two sets of coordinates are going to be 1 plus root 2 negative 2 root 2, and 1 minus root 2, 2 positive root 2.